Imagine if I told you that every single second, hundreds of KitKat bars are being snapped, wrapped, and shipped somewhere in the world. Not every minute, every second. That means while you blink, a small mountain of chocolate-covered wafers just left a factory line. But here's the part most people don't know. A KitKat isn't just chocolate poured into a mold. Inside that smooth coating is a carefully engineered structure of ultra-thin wafers, layered cream, recycled chocolate crumbs, and precision timing so exact that if one machine slows down by even a few seconds, the entire production chain collapses. So how does a simple snack become one of the most precisely manufactured chocolate bars on Earth? And what really happens behind those factory walls? This is Infusions and Elements, where we break open the world's biggest factories and reveal the hidden systems behind everyday products. If you're curious about how things are really made, subscribe to Infusions and Elements and step inside the machines most people never get to see. Now let's go deeper. The big question. When you break a KitKat, it snaps clean. Perfect layers, perfect sound, perfect shape. That snap isn't an accident, it's engineered. The real question is, how do factories create millions of identical bars every single day without losing that perfect crunch? To understand that, we have to start long before the chocolate touches the mold. From cocoa bean to liquid gold, every KitKat begins with cocoa beans. These beans are harvested from cocoa pods grown in tropical regions. Once fermented and dried, they travel thousands of miles to massive processing plants. Inside the factory, the beans are roasted at carefully controlled temperatures. Too hot, they burn. Too cool, the flavor stays flat. After roasting, the shells are cracked and separated, leaving behind cocoa nibs. These nibs are ground into a thick paste called cocoa liquor. Despite the name, there's no alcohol, just pure cocoa solids and cocoa butter. Now comes refining. Heavy steel rollers crush the mixture again and again until the particles are so fine you can barely feel them between your fingers. Then the chocolate enters a process called conching. Huge machines mix, aerate, and heat the chocolate for hours, sometimes even days. This smooths the texture and removes unwanted acidity. By the time it's done, the chocolate flows like silk. But chocolate alone doesn't make a KitKat. The real magic lies in the wafers, the wafer engineering. Here's something surprising. The wafer inside a KitKat isn't randomly stacked. It's engineered with mathematical precision. The process starts with a simple batter made from flour, sugar, and water. It's poured onto enormous heated plates that look like oversized waffle irons. In seconds, thin sheets bake into crisp wafer layers. Each sheet is only a few millimeters thick, light, fragile. Now imagine stacking hundreds of these per minute without breaking them. Machines do it effortlessly. A thin layer of cream filling, made from sugar and finely ground cocoa crumbs, is spread evenly between each wafer sheet. And here's the twist. Those cocoa crumbs? They often come from broken KitKats that didn't pass quality control. Nothing is wasted. The imperfect bars are crushed and blended into the filling. So every KitKat secretly contains recycled pieces of earlier batches. A chocolate cycle within a chocolate cycle. Layer by layer, wafer and cream are stacked. Usually 3 wafer layers, 2 layers of filling in between. Then heavy pressure compresses the stack into one solid block. It rests briefly to stabilize, because if it moves too soon, it cracks. Cutting with surgical precision. Once the giant wafer slab is ready, it moves forward on conveyor belts that never stop. Rotating blades slice the slab into long fingers. These blades move so fast, they blur to the human eye. One slight misalignment, and thousands of bars could be ruined. The fingers are spaced apart evenly. Why? Because chocolate needs to flow around them perfectly. And that next stage is where things get mesmerizing. Emid Video CTA. And if you're enjoying uncovering these factory secrets so far, make sure you're subscribed to Infusions and Elements. Because every week, we open the doors to another massive production line. And once you see how things are truly made, you'll never look at them the same way again. The chocolate waterfall. The wafer fingers travel into what looks like a curtain of flowing chocolate. A continuous waterfall. Each piece passes underneath as liquid chocolate cascades over it. Top, sides, bottom, every surface coated in seconds. The flow rate is precisely controlled. Too much chocolate, waste increases. Too little, the wafer peeks through. Air blowers gently remove excess coating to create smooth edges. Then something critical happens. The bars move into a cooling tunnel. Inside, temperature and humidity are tightly regulated. Chocolate must cool gradually. If it cools too fast, it turns dull and brittle. Too slow, and it loses shape. The cooling tunnel can stretch for dozens of meters. By the time the bars exit, the chocolate has solidified into that glossy, familiar shell. And now comes the part that defines everything. The snap formation. That clean snap when you break a KitKat? It depends on alignment. The chocolate coating must bond perfectly with the wafer layers beneath. If the internal structure shifts even slightly, the snap becomes uneven. Factories use vibration systems and precision spacing to make sure each finger sets evenly. It's almost like tuning a musical instrument. The pressure, the cooling time, the coating thickness, all calibrated. And here's something incredible. Some high-speed production lines can produce thousands of bars per minute. That's faster than a human could blink repeatedly, all while maintaining identical size and weight within fractions of a gram. Quality control teams constantly test samples. They measure thickness, they test break strength, they even analyze sound frequencies of the snap. Yes, the sound matters. Wrapping at lightning speed. Once the bars pass inspection, they don't slow down. They accelerate into one of the most intense stages of the entire operation, packaging. What happens here feels almost unreal. Massive rolls of printed foil unwind at high speed, feeding into a network of rollers and folding mechanisms. The material is cut, shaped, and positioned with millimeter accuracy. Each KitKat bar slides into place at precisely the right moment. In a fraction of a second, it's wrapped, sealed tight, stamped with batch codes, and pushed forward without breaking rhythm. The machines operate so quickly it almost looks like time-lapse footage, thousands of identical movements happening every minute. No hesitation, no wasted motion. Robotic arms then lift and arrange the wrapped bars into cartons with flawless symmetry. Every row aligned, every box packed with mathematical precision. Sensors constantly monitor the line. If a single wrapper shifts out of position or jams, the entire system can pause instantly to prevent damage. In a factory running at this scale, even a few seconds of delay can mean significant loss. And yet, the system keeps flowing. Relentless, precise, unstoppable. If machines can wrap chocolate this perfectly, what other everyday products are being assembled with this same hidden precision? Subscribe to Infusions and Elements and uncover more factory secrets you were never meant to see. The scale you never see. Across the globe, billions of KitKat bars are produced every single year. That number is almost impossible to visualize. Entire factories run 24 hours a day, 7 days a week, rarely going silent. While one batch moves through cooling tunnels, another is already baking into crisp wafer sheets. While one pallet is being loaded onto a truck, another is being sealed and labeled just meters away. Everything overlaps, nothing stops. It's a continuous choreography of steel conveyors, controlled heat, synchronized robotics, and split-second timing. Each stage depends on the next, forming an industrial rhythm that never breaks. And here's the surprising part, most people will never think about any of it. They'll unwrap the bar, hear that clean snap, and move on. Behind that simple break is a global system designed for speed, precision, and scale far beyond what we imagine. The final stage from factory to your hand. After packaging, cartons are stacked onto pallets. Automated forklifts move them into distribution centers. From there, trucks carry them to stores across cities, countries, even continents. Temperature-controlled transport ensures the chocolate doesn't melt. Logistics systems track every batch, from cocoa bean origin to production line to retail shelf. A journey measured in thousands of data points. And somewhere along that journey, one bar ends up in your hand. You tear it open. You hear the snap. You taste layers that traveled through roasting drums, steel rollers, cutting blades, chocolate waterfalls, cooling tunnels, and robotic packaging lines. All for a moment that lasts seconds. That's the strange beauty of mass production. An enormous industrial symphony, reduced to one simple break, one crisp snap, one bite. Behind every KitKat is a hidden world of engineering, precision calibration, recycling systems, temperature science, and machines moving faster than human thought. It's not just chocolate, it's timing, structure, control. A product designed to feel effortless in your hand, but built through relentless industrial precision. Now you know what most people never stop to consider. The next time you snap a KitKat, you won't just hear a break, you'll hear the echo of an entire factory moving in perfect synchronization. If you enjoy uncovering the hidden systems behind everyday products, make sure you subscribe to Infusions and Elements and become part of a community that looks beyond the surface. And tell me in the comments, which factory should we enter next? Coca-Cola bottling plants, luxury car manufacturing, or something even more unexpected? Because once you truly see how things are made, You never look at them the same way again.